So let's go ahead and put some logic gates on this circuit. So the shortcuts for the logic gates are quite simple. They're just the numbers along the top. So if you press 1, drag it across, you'll see we have a NOT gate, otherwise called an inverter. Press 2, drag it across, we have a 2 input AND gate. Press 3, we have a 2 input OR gate. And if we press T, we can put on some text. Comes up with the word hello. If you just double click, we can change that. So logic circuit for A and B or not C. And remember to press escape if you want to get out of drawing mode and back to pointer mode. So let's get this put together then. A and B or not C. We're going to need some inputs here. Shortcut for input is I. So we're going to need 3, and I'm just dragging those from right to left. They come up with a little L on them, and L is for low. So you'll see if you click on, you can set the input between high and low, which is of course 1 and 0. My whole circuit is a little bit off to the left here, so I'm going to draw a box around the whole thing and then grab it somewhere in the middle and reposition. I can also, using the mouse wheel, zoom out or in. So I want these inputs to be A, B and C, so I need a little bit of text beside each one. So having put on an A, the easiest thing to do then is just to draw a box around that and copy. And then double click it to change to B. Same again. And we can set that to C. So these are just text boxes. I don't have any operation on the circuit itself, but this is just showing that these are inputs A, B and C. For an output then we can press O and we'll drag it again from left to right. Okay, so it's time to connect it up. A and B are going into an AND gate. So we can position our AND gate here and we can wire those together. Press W, and it's best not to have diagonal wires as such, so I'll put 2 wires in here. So that gives us A and B, and then we need not C. So here I'm just going to drag it over and set it on the end to make a connection. Now it's best not to drag these gates too far in order to make connections, because you can end up with the gate kind of becoming a crazy shape. I'll show you here on this OR gate. If we bring it up too small, we kind of lose the wires in. So it's better to keep the gates pretty small and just use wires between them. So there we go. I'm going to deliberately drop this one in the wrong place so that you can see the 2 red dots. So it looks as if the circuit's built properly, but the red dots are telling you they're not connected. So there we go. A and B here, AND gate, A along with B into it. And then C goes through a NOT gate, not C, and both of those are joined with an OR gate. And in order to run through the different combinations, we can simply turn the input here on and off. And you can see some combinations will bring the output on, others not, and that should follow the results from your truth table. So the top line in the truth table, remember, is 0, 0, 0. So to simulate that, we put in low, 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 and we should find that on the truth table, the top line is, the output is a 1 for 0, 0, 0. And we can use this tool to check all of the outputs in the truth table. And as long as the circuit coincides with the truth table, we know that it's built properly.